All right, guys, gonna go through some concepts. Now, what we're creating here are equivalent expressions. So not the final answer, but we're creating something that is the same as this, but simpler. So we're simplifying almost. All right, so for these questions, 3 to the fifth times 3 to the second. Okay, the number 3 is consistent all the way through. So the answer is also going to be 3. Okay? And the exponents always do a step less than what you think they're doing. So it says multiplying. So what's easier than multiplying? Adding. So these top here are going to be adding, making 5 to the 7th power. Okay? Hopefully I'm not muted. Okay, so eat. Okay, so this next one here, so why is that true? Because 3 to the 5th power, okay, so this right here is 3 times 3 times 3 times 3, 3, and times, this is going to turn into 3 times 3, right? So what does this come out to? It's 3 to the 7. Same work, but way simpler to see, okay, as an end result. So that's what's going on. That's why the exponents just add. Boom. Okay? Now, if you add when you multiply, what do you think you do when you subtract? When you divide? Oh, I said the answer. Cassers. So you subtract here. So the 5, again, is going to stay consistent. And exponents always do a step down. So division, what's easier than division? Subtraction. So we're going to say this is 6. Okay? Why does that work like that? So 5, there are 9 of them. I don't know why I did it. So such a big number. 1, 2, 3, 4, 5, 6, 7, 8, 9. Divided by, right? Now they cancel. These cancel each other out because we're multiplying and dividing. And then what's left is 3, 3. 5 to the 6th power. Okay? Let's go to the next one. Now again, the 5 is consistent all the way through. So now we know that the exponent says the 5. Oh no, what do I do with the numbers down here? Bases, okay, when they're the one that's going to change, they act normal. 2 times 4, 8. Okay? Why is that? Because 2, okay, times, okay, so 2 times 4, okay, is going to happen 5 times. So 2 times 4, this 2 times that 4, this 2 times that 4, this 2 times that 4. Okay, so that's going to happen 5 times. So 8 is going to happen 5 times. Okay, I don't have to erase this. I'm just going to keep on sliding. All right, so next one. The 7 stays consistent in this answer. Okay, now an exponent with an exponent. Okay, what's lower than exponents? Multiplying. So these two are going to multiply. So they're going to make 10. Exponents usually do not multiply like that. Okay, it's this, 7 to the 2nd power times 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 7 to the 2nd power. That's what to the 5th power means. But these are going to add because they're multiplying. And if you add all those numbers up, you're going to get 10. It's repeated addition. And what's repeated addition? Multiplication. All right. Okay, this one. Any number to the power of 0, except for 0, equals 1. So 19 to the power of 0 equals 1. What about 1.9? Also equals 1. What about 11.9? Also equals 1. What about 111.9? That also equals 1. The only number to the power of 0, okay, that's it. All other numbers, any number in the entire world is going to give you 1 as long as it's not 0. Okay? Any number to the power of 0 equals 1. So if I did 3 times 5 to the power of 0? The answer is 3, because this is 3 times 1. All right, this one over here. So negative exponents are now a thing, right? Negative exponents do not mean the number is negative. Negative exponents mean I'm on the wrong side of the fraction. Now, this might not look like a fraction, but every number is a fraction. This number 3, there you go, it's a fraction. Okay, so this is a fraction. So that 17 to the 5th power is on the wrong side. That's why it's a negative. So when I put it on the correct side, so I'll put a 1 on top and the 17 to the 5th power, the negative sign vanishes. So if I ask you to write this number with a positive exponent, this is what you would do. You would put it in its correct spot, and now it's a positive exponent. Okay, so this is a very small number. 17 to the 5th power underneath a 1 in a fraction, that's pretty low. Now let's see this. 10 to the negative 3. This one isn't a fraction, and it's telling you I'm on the wrong side of the fraction. So I belong on the top of the fraction. So 10 to the 3rd power divided by 1. Well, I don't need divide by 1 because that's just going to make 10 to the 3rd power. So this would be how you do this one. Remember, the negative sign is saying I'm on the wrong side of the fraction. So when I put you on the correct side of the fraction, it becomes positive. Now here, scientific notation. When you write scientific notation, a number has to go in this box. This never changes. And then a number goes in that box there. So let's see. There's a decimal point here, okay? And it's right here. I have to move that decimal point to a location that makes 850,000 into a number less than 10, but more than 1. So here it is, 8.5. If I would have gone too far, it would have been 0.85, which makes it less than 1. That's unacceptable. If I would have left it at 85, that's more than 10. That's unacceptable. So that's the only place it could go. Now look at this. How many times did I have to move this decimal point? 1, 2, 3, 4, 5 times. So that number goes there. All right, let's look at this. Again, we're writing this in scientific notation. So there's a number that goes here. This never changes. And there's a number that goes there. Okay, so now I have to move this decimal point to its new location. 1, 2, 3, 4. There we go. 1.1 would meet the expectations. 1.1. If I went too far, it would be 11. That's more than 10. It's not allowed to be more than 10. It's not allowed to be less than 1. So if I would have cut it here, it would have been 0.11. That also would have been wrong. So 1.1 goes here. Now, how many times did I move that decimal point? 1, 2, 3, 4. I moved it 4 times. But because you're going in the opposite direction, this number needs to be the opposite number. So it doesn't get to be positive 4. It has to be negative 4, which makes this 1 over 10, which means you're dividing, and that would make a smaller number. So when this number is small, it's going to be a negative sign. When it's big, like 850,000, the number is going to be positive. Okay? Does that sign have anything to do with negative or positive? No. Here, now they did the scientific notation. We're going to write the new number. So I start with 3.2. And now I'm going to move this dot 5 times. And remember, it's positive 5, so this is going to be a big number. So I'm going to make it bigger. 1, 2, 3, 4, 5. Here's my new dot, and all of these should fill in with zeros. Now that I know what it's supposed to look like, I'm going to write my new number, 3, 2, 0, 0, 0, 0. Put some commas, perfect. If you leave this answer, it's incorrect. You've left a number with 2 decimal points. So make sure it looks like that. And then the last one here, 4.8, okay? 4.8, and I'm moving it, making it smaller, so it's going this way, and I'm moving it 8 times. So 1, 2, 3, 4, 5, 6, 7, 8. Here's its new location. So check these zeros out. Okay, so you can write point, and I have 7 zeros, and then 4, 8. You see, I didn't leave that decimal point there because we're moving it. We're moving it over here. Okay, and you can put a 0 here too. That's the same number. So you can put a 0 there or not. It is the exact same thing. So that's it. All right, those are lessons from this week. Good luck, guys.